today's video. It's all about pressure testing my castings, and this is the pattern I will be using, and it will be poured in cast iron. And what will happen is I'll be drilling a hole through there and putting a pressure gauge through there, and this is the lid. I need two of them, one for there and one for there, and I'll be drilling a hole through there, and we'll put a grease nipple in and we'll pump it up with a grease gun and we'll get the pressure what we want, and we'll see if it will leak. So this is how I'll be gauging this casting. I'll be putting an in-gate in here, and this will be a dual function thing. It will be the sprue as well as a riser. Because I will be putting the gauge in there, screwing it in there, it cannot have any cavities or holes in there, otherwise they'll leak. So this is the idea. If I pour it down here, it'll have plenty of metal and it'll have enough metal to compensate for a shrinkage. I would like to get the most highest tensile strength I can get, so what I'll be doing is, remember this stuff here, this is out of the hard drives. It's not nickel alloy, but it is a good alloy to put in because it's a low carbon steel, and it will lower the carbon content of the cast iron, so it should increase the tensile strength. This is the last thing that I need. It's the core to provide the hollow shape inside the casting, and this one here, there's no vents, and you'll see a bit of a hole there. That's not a vent, that's a piece of steel wire I pushed down there to reinforce the core so it doesn't break, because when you pour iron around this core there's a lot of pressure in the middle there and sometimes they can break. It's an insurance policy. Here is a close-up of the core, the end. You can see a piece of coat hanger wire which I've used to reinforce the core. This is the way I use a one-piece pattern. As you can see there, it's one piece, it's not split. All I do is just go like that and push it into the sand. Then I just put the top box on top and then sieve some more sand on and continue. Top box is on, and what I've added is one of the lids. I've got to cast two of them for that part. So what we do, we sieve on the facing sand so it just covers the pattern. The boxes have been flipped over. This is the first half you saw me make. This is only temporary, it'll be knocked out again. So what I do, I just lift it up, then what I do, I have to go around, dig all that out and bring it back to the parting lines. I've trimmed all the parting line around here, and this one here is a one-sided pattern, so the parting line is automatically created. Now we slip on the top box, and the same thing's repeated again. We just sieve facing sand over there and make the second half of the mould. This is the moment of truth time, and now we'll see whether I've done an excellent job of the parting line or a really lousy job. Looks good so far, but I still have to pull the pattern out of the sand in the other half. The patterns have been removed, and it did break away just where that vent wire is pointing to. You'll see it in the flange. There's the core in place. Now we'll stick the top box on, the coat. This is the mould for the pressure test casting. As you can see, there's no vents in there. And the same for the next mould. It's got no vents in it. Here we go, after the pour. There's two separate castings in the first mould, that's why there's two sprues. And the second one, same thing again, there's two separate castings, two separate sprues. And I was hoping this mould would take the rest of the metal, but it did not. Still got a fair bit left over, which is a real waste. And there is our all-important wedge test. Did you see how many times I had to hit it with the hammer to break that wedge test? Well, the quickest way to raise the tensile strength of cast iron is to add some steel to it. This is the first mould I poured with the core. We'll have a look and see how this turned out. So the first thing I want to look at, there's the core print. Now have a look at that. Have a look at the sand that's inside there. Look at this. It just falls out. There's a reinforcing wire that I used. This is why I like using the resin, because as it burns out, there's very little problem in getting the core sand out. I've cleaned up the castings and now I'll have a quick look at them. Now have a look at the first thing I'll show you. See the mark I've put there? That's only about 26-27 millimeters, and that head pressure between there and there is all you need to fill up that mould. And there's no need to put any air vents in there because they fill up so easily. And then here are the covers. That's how they go on, like that. All the relevant surfaces have been machined. There's one face, there's the other face, that one, tapped hole, and then the bore's been done. You can see the hole where it comes through there. That's where the gauge is going to sit. Now I've cut out the O-ring groove and we'll try the O-ring. This will seal the pressure in both covers. There we go, done. This is the test piece. It's all been assembled. They've got the gauge and there's O-rings in between so it doesn't leak. Then what I've got to do, I've got to fill this up full of oil and then screw in the grease nipple. See it there, screw that in there and then just keep pumping and see what the gauge goes up to, and we'll know when it fails is when it won't hold pressure. I've got the grease gun connected, so what I'll do now, I'll just keep pumping. Ooh, that went up quick. Now I haven't got a decent gauge in kilopascals, so this one goes up into 3000 psi. Yeah, 1000, I'll tell you what, it's taken a fair bit to hold up there. Well, the pressure's holding, so we'll keep going. We've got 1500 psi. pressure is holding. Oh. So we've got 2000 psi, pressure's still holding. This is getting really hard to pump with the grease gun. That's 2500 psi. So my gauge won't be big enough. We'll go to 3000. Well, there you go, 3000, and it hasn't failed. This is where you have good quality castings. I have made pressure castings in the past and they leaked like the sieve, but this one here is working really well. It's been about 15 minutes and the pressure has dropped a little bit. There's no external leaks what I could see. What the problem is, the grease gun has leaked a little bit through the fitting and the grease nipple. That's the grease gun I've used. Works quite well as a pressure tester. As you can see, the pressure's dropped quite a bit. It's been about an hour since I've done that pressure test and I've found the leak. And you can see there, the grease nipple fitting is just leaking grease. And I'll continue to do so until it drops to 0. Cut the casting in half, so what I'm interested to see is the surface there between the bore and the cylinder and where I've machined it there, and we'll have a closer look at it. So I'll go across to here, and this is the mating half I cut off. Well, I think that turned out pretty good, considering it's only a steam engine cylinder and it's only meant to run between 50 and 100 psi, and I tested it to 3000 psi and it never failed. It worked really well. This is a casting that I pressure tested about 10 years ago. It failed in a very spectacular way. The crack started here and then moved all the way along through the boss and ended about here. So what I'm saying is this was taken to 4900 psi and I went to pump on the grease gun again and it went off with a loud bang. And I was very fortunate that that crack was facing away from me and sprayed oil all over my shed wall. So if you do pressure test castings, be very careful. This metal stretched, it's like a balloon, and that's why the crack opened. Normally when I pressure test castings they'll fail, they'll just leave a little crack and they'll weep oil, but this one failed in a big way. So if you're wondering what this is from, this is a pressure head from a Maxxon piston pump. I'll give you a quick look around it. There's the Maxxon name. There. And we'll have a look at one end. That's where the core print is in one end. And then we go through the other end. And there's a core print at the other end.